What is machine learning? In simple terms, machine learning means a machine that learns. Machine learning is a branch of artificial intelligence which focus on enabling computers to perform tasks based on data and with minimal human interference. I should make it clear that the ultimate aim of machine learning is to build intelligent systems which can learn from data, identify patterns, and make decisions to help humans, not to replace them. Nothing can replace humans. This description and definition of machine learning is for non-technical people who doesn't want to build career in this area. Let's discuss machine learning with an intention to build a career out of it. Before understanding machine learning, we should answer what is learning. Learning is the ability to improve one's behavior with experience. It means learning is continuous process of doing a task, evaluating result of that task, improving based on the result, and doing the task again in a better and efficient way. For example, a marathon runner runs for a couple of miles, evaluates his performance, works on his performance and runs again. What is machine learning? Machine learning is the study of computer algorithms that learns and builds models from data. These models can be used for prediction, decision-making or solving tasks. A computer algorithm is said to learn from experience E with respect to some class of tasks T and performance measure P if its performance of tasks T is measured by P improves with experience E. Difference between traditional programming and machine learning. In traditional programming, a programmer or a user writes a piece of code or program and input data into a computer in order to get a result or output, whereas in machine learning, user has to supply computer with data and output. The computer then builds a model or program to increase the efficiency and accuracy of the task. Suppose we take an example of a credit card system. By using traditional programming, we can get information like who is paying the bills on time and who is not based. But if we apply machine learning, we can use data such as income, expenditure, demography, etc. to determine whether the person will or will not pay the bill on time. Architecture of machine learning. If we consider machine learning system as a box, there are two main components in it. Learner. Reasoner. Learner takes experience and background knowledge to build model. This model can be used by the reasoner to find a solution of a task provided to it. Types of machine learning. There are mainly three ways in which a machine learns. Supervised learning, unsupervised learning, reinforcement learning. Do you know what supervised learning is? Let's dive in and understand supervised learning, the most common and widely used branch of machine learning. Imagine you are a student learning a new language. You'll need a teacher to explain different words and their meanings. Once you understand and memorize these words, you can form sentences and eventually speak and write in that language. This entire process happened under the supervision of your teacher, which makes it a perfect example of supervised learning. Similarly, in supervised machine learning, a set of examples, called instances, is provided to the learning algorithm. Each instance contains both an input and an output. The algorithm studies these examples and builds a model, which can then predict the output for any new input. In other words, you show the machine the connection between variables and known outcomes. This is what we call labeled data. That's why supervised learning is often described as learning with labeled data. For example, suppose you want to build a program that can identify different types of vehicles on the road. To train the algorithm, you would feed it images of cars, bikes, and trucks and assign labels to each image. This process is called training the algorithm. Once training is complete, it's time to test it. During testing, you provide new images of vehicles without labels. The algorithm analyzes each image and assigns the most likely tag. If the tag is correct, the training was successful and the machine has truly learned. Supervised learning uses many algorithms, which can be broadly divided into two main categories. Number 1, classification. Number 2, regression. What is unsupervised learning? The basic idea of unsupervised learning is to feed the machine with a large amount of data without providing any labels. The machine then groups similar data together to form clusters and provides insights from them. In unsupervised learning, the algorithm tries to understand relationships between inputs without any prior information. In other words, only inputs are present, and the algorithm organizes them into clusters. For example, imagine visiting a religious site of a faith different from your own. At first, it might be difficult to understand the rituals being performed. So, you start observing people around you. Are they folding their hands, and if so, how? Are they moving in a particular direction? Are they chanting? What kind of clothes are they wearing? Are they offering something to the idol? By noticing these patterns, you begin to understand what to do. You may not know the meaning of the rituals, but you can still perform them. The same process happens in unsupervised learning. The machine takes the data, groups similar data together without knowing what it means, and we use these groups to gain insights. Unsupervised learning has many practical applications. It can group customers based on their purchase history. It can group patients based on their medical conditions. It can also group different types of viruses, which helps in finding cures. One of the biggest advantages of unsupervised learning is that it often reveals unexpected patterns or insights that may not be discovered through supervised learning. So, what happens when we combine supervised and unsupervised learning? We get semi-supervised learning. This approach uses a large amount of unlabeled data along with a smaller amount of labeled data. It helps us gain insights from both known indicators and unknown patterns, making learning even more powerful. What is reinforcement learning? Reinforcement learning is a branch of machine learning used when there is no training dataset available, and the goal is for the machine to learn from its own experience. Instead of being told the correct answers, the machine, also called the agent, learns through interaction with its environment. How reinforcement learning works. 1. A problem is given to the agent. 2. The agent uses trial and error to find a possible solution. 3. For each action, the agent receives feedback from the environment in the form of rewards or penalties. 4. The agent learns from this feedback and tries again to improve its performance. 5. This loop continues for many iterations. 6. The ultimate goal of the agent is to maximize the total reward. Architecture of reinforcement learning. Input, the initial state from which the model begins. Output, multiple possible solutions, since there can be many ways to solve a problem. Training, the model explores different actions. Based on the output, the environment or user provides rewards or penalties. Over time, the model learns and selects the actions that lead to the highest cumulative reward. Difference between supervised and reinforcement learning. In supervised learning, the feedback is a correct set of outputs for given inputs. In reinforcement learning, the feedback comes as rewards or penalties for the actions taken, not the exact correct answer. Difference between unsupervised and reinforcement learning. Unsupervised learning focuses on finding similarities, patterns, and differences in data. Reinforcement learning focuses on discovering an action strategy that maximizes the total cumulative reward of the agent. Applications of reinforcement learning. Reinforcement learning has wide-ranging applications across industries, including gaming and simulations, robotics and autonomous systems, industrial operations and automation, supply chain optimization and logistics, traffic management and control, bidding and advertising strategies, advanced natural language processing. Reinforcement learning is powerful because it allows machines to improve through experience, just like humans learning from trial and error.